A pleasant greetings to all. In this video, I am going to solve some of the IES gate problems in electric circuits. A 12-volt automobile light is rated at 30 watt. The total charge that flows through the filament in 1 minute. So what are the data given in the problem? The first one is voltage is given, that is 12 volt. Another one, power is given 30 watt. Time also given in 1 minute, so you have to convert this 1 minute, that is equal to 60 seconds. Now I am going to find out the charge Q. How to find out? What is voltage? Voltage is known as work done per unit charge. So what is work done? Work done is otherwise known as energy. So energy by charge. Energy is power into time divided by charge. So now in the next step, what is Q? Q is P into T divided by V. The power is given, power is 30, time also given 60, that is equal to 12. So 12 5s are 60, that is 150 coulomb. This is the answer for this problem. If the length of the wire of resistance R is uniformly stretched to n times the original value, what is the new resistance is? So original value of resistance have to take as R1 and the new value of resistance, that is R2. Okay, now have to stretch the length to n times the original value. The volume is remains same. V1 equal to V2. So volume is what? Area into the length. Here also area into length. So n time, this stretched n time to its original value. So now A1 into L1, A2 into, that is n times the original value, n into L1. L1 cancel. What is A2? A2 is A1 by n. Now we are having two relations. One is A2 equal to A1 by n and L2 equal to n into L1. Next I am going to write R1. What is R1? R1 equal to rho into L1 by A1. What is R2? R2 equal to rho into L2 by A2. Have to substitute the value of L2, n into L1. What is A2? A1 by n. So from this I have to separate rho into L1 by A1. Remaining I am having n into n, that is n square. So now what is R2? R2 equal to n square into R1. R1, that is almost equal to R. So what is answer? N square into R, that is the new resistance R2. Next problem. What happens to the resistance of a conductor if its length is increased 3 times and diameter is solved? So old resistance have to take as R1, that is rho into L1 by A1. And new resistance is R2, that is rho into L2 by A2. See, the length is increased 3 times the original length and diameter is halved. So L2 is 3 into L1, but here diameter is given. Diameter D2 is half, D1 by 2. Okay, now have to expand this rho into L1 by, what is A1? Pi by 4 into D1 square. That is R1. What's the new value? R2 equal to rho into L2 by 5 by 4 into D2 square. That is equal to what? Rho into, instead of L2, have to put 3 into L1. And instead of D2 square, have to put what? That is D1 by 2 the whole square. Now, what is the answer? That is 2 square 4. So, 12 into rho into L1 divided by 5 by 4 into D1 square. So, what is the answer now? 12 into the old resistance R1. So, now what is the new resistance? R2 is 12 times the old resistance R1. So, this is the answer. Next, a drawn wire of resistance 5 ohm is further drawn so that its diameter become 1/5 of its original. What is its resistance with volume remaining the same? Okay, here the diameter, new diameter is 1/5 of the original, D1 by 5, that is given. Old resistance R1 also given, that is 5 ohm. Okay, now have to take the old resistance as R1 equal to rho into L1 by pi by 4 into D1 square. So what is R2? That is rho into L2 by pi by 4 into D2 square. See here, I am going to find out the new value of resistance. The condition, what is the condition given? Condition is volume 1 equal to volume 2. So what is volume 1? That is A1 into L1 equal to A2 into L2. Okay, now I am going to substitute the value pi by 4 into D1 square into L1, pi by 4 into D2 square into L2. Okay, now D2 is given. Okay, so again write 5 by 4 into D1 square into L1, that is equal to pi by 4 into, what is D2 square? D1 square by 25. Okay, into L2. Okay, now D1 square get cancelled, pi by 4 get cancelled. So what is the value of L2? L2 is 25 L1. Now I got the two relations. One is L2 and another one is what? Another one is D2. Okay, after finishing this, what I have to do? I am going to find out R2. So what is R2 now? Rho into, I have to put the value of 25 L1 instead of L2. Okay, the whole divided by 5 by 4 into, what is D2 square? What is D2? D1 square by 25. Correct. And next, 6,000, sorry, 600 and 625 into rho into L1 by pi by 4 into D1 square. So that is equal to what? That is the resistance, old resistance R1. That is 5 ohm. Now what is the new resistance? 3125 ohm. This is the answer for this problem. Next, the hot resistance of the filament of a bulb is higher than the cold resistance because the temperature coefficient of the filament is positive. The answer. Whenever the temperature increases, the resistance also increases. Okay, both are increases. So that hot resistance of the filament of a bulb is higher than cold resistance. That is the reason. Temperature increases, resistance increases. That is positive temperature coefficient. The next, three parallel resistive branches are connected across DC supply. What will be the ratio of the branch currents I1, I2, I3 if the branch resistance in the ratio R1 is to R2 is to R3? Okay, that is given. That is 2 is to 4 is to 6. Okay, now I am going to find out the ratio of current. So what is the ratio of current? I1 is to I2 is to I3. That is equal to what? That is equal to 1 by R1. That is the relation between current. 1 by R2 is to 1 by R3. Isn't it? So I1 is to I3 is to, I2 is to I3 equal to 1 by 2 is to 1 by 4. That is to 1 by 6. Now I am going to take the LCM for 2, 4, 6. So 2, 4, 6. So 1, 2 and 3. So 12 is the LCM. What I have to do? I have to multiply 1 by 2 is 12 is to 1 by 4 into 12 is to 1 by 6 into 12. So what is the ratio now? That is 6 is to 3 is to 2. So this is the ratio. The next problem. The same type of problem here. Three parallel branches of resistors are connected across the DC source is given. What is I1 is to I2 is to I3? That is the question. So I1 is to I2 is to I3. That is equal to what? R1, 1 by R1, the same, is to 1 by R2 is to 1 by R3. Okay. Next I have to substitute the values here. 2R, 1 by 4R, 1 by 6R. So this is 2. Okay, now all the R's are get cancelled. Same. Okay, now what I have to do? I am going to take the LCM. So the LCM equal to 12. Now multiply 12 with each term. Now I get 6 is to 3 is to 2. That's all. This is the answer. Next, for the circuit shown below, the equivalent resistance will be. Here, no need to bother about this portion. So I am going to find out the equivalent resistance. So for finding out equivalent resistance, what I have to do? I have to mark the terminals 1. The same one is connected here. And here 2, the same 2 is connected here. So next what I have to do? I am going to mark the 1 and 2. So I am going to mark 1, here 2. So first see here between 1 and 2 one resistance. 1 and 2 another one resistance. 1 and 2 another one resistance. Now the 3 resistances are connected in which combination? That is in parallel combination. So 3 resistances are connected in parallel combination. 3 are the same resistances also. Okay, now how to find out R equivalent? R equivalent equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Okay, how to find this? 1 by 1 by 12 plus 1 by 12 plus 1 by 12. So from this equation we get 1 by 3 by 12. Okay, 1 by 1 by 4 or 4 ohm. 4 ohm is the correct answer. Next problem, 12 1 ohm resistance are used as edges to form a cube. The resistance between two diagonally opposite corners of the cube. See here, this is the cube. All resistance are same. This is the diagonally opposite corners. Now I am going to find out the resistance in between them. So first I am considered one voltage is connected between the corners. So the voltage source is taken as V. Because of the voltage source, the current is flowing here. That current is I. Now the I is divided into 3 equal parts. I by 3, here I by 3 and I by 3. Now this I by 3 is divided into 2 equal parts. I by 6 and here also I by 6. Now this I by 6 is divided into 2 equal parts. That is I by I by 6 and then this I by 3 is divided into 2 equal parts. That is I by 6 and I by 6. Sorry, this I by 3 and I by 3 both are combined together. So that is I by 3. And this I by 3 is again divided into 2 equal parts. That is I by 6 and this one is I by 6. Now this I by 6, this I by 6 meet together and we get I by 3. And this I by 6 and this I by 6 meet together, we get I by 3. Now these 3 I by 3 meet together, finally we get I. Now I am going to consider this as a closed loop. This is a closed loop and I am going to apply, this is the loop direction and I am going to apply the Kirchhoff's voltage law here. So apply KVL. So what is the answer here? B. And voltage rise. Here voltage drop, that is minus I by 3 and then minus I by 6. Here this one is minus I by 3, that is equal to 0. Okay, see here V minus, what is the LCM? LCM is 6. So 2I minus I minus 2I equal to 0. So V minus 5I by 6 equal to 0. So V is equal to what? 5I by 6 or what is V by I? That is 5 by 6 ohm. So this is the answer. The correct answer. So I am going to explain N resistors. Each of the resistance are were connected in series offer an equivalent resistance of 50 ohm and when reconnected in parallel, the effective resistance is 2 ohm. What is the value of R? So when N resistances are connected in series, so consider R1 plus R2 up to Rn. That gives the equivalent resistance of 50 ohm. But all the resistance are equal. So R1 plus R2, R1 equal to R. So R plus up to R. So that is equal to what? N into R. If R plus R equal to 2R, R plus R 3R. Now N resistance means that is NR. Okay, so NR equal to what? The NR equal to 50. Now, these two resistances are reconnected. These two resistances are reconnected in parallel. The effective resistance is 2 ohm. That is also given. So parallel means what? 1 divided by 1 by R1 plus 1 by R2. All are R, no? So 1 by R. How to write this? R1, R2, then Rn. So we can rewrite like this. That is 1 divided by N. So N resistance, no, N by R. That is equal to what? 2. So R by N equal to 2. Now I got two equations, equation number 1 and equation number 2. So 1 into 2. What is the answer? N into R into R by N, that is equal to 50 into 2. Both the n's are get cancelled. So R square equal to 100. R equal to plus R minus 10. Have to take the plus ohm. Normally the resistance we have written as plus value only. So plus 10 ohm. That is the answer. Next problem. The current of 2 ampere passes through the cell of EMF 1.5 volt having internal resistance of 0.15 ohm. The potential difference across the terminal of the cell is. Okay, now I am going to draw this. First I am going to draw the cell. The 1.5 volt that is connected having the internal resistance, and I am going to find out what across the value, the potential difference across the terminal. So I am going to find out V. What is the potential difference? The current flowing through is 2 ampere. 2 ampere is the current is flowing through this. The potential, cell potential is given 1.5 volt. Here this one is 0.15 ohm. Now I am going to write the equation. This is voltage rise and then voltage drop 1.5. Again voltage rise, negative to positive, no, voltage rise, that is plus 0.3, that is equal to 0. So V minus 1.2 equal to 0. V is equal to 1.2 volt is the correct answer. Next problem. In a parallel resistive circuit, opening a branch results in. Here I am going to consider this parallel resistive circuit. Here the value R1 and this one is R2. Okay, see here in the parallel resistive branches, I am going to remove the resistance. So remove the resistance means here it is open circuited. The terminal is opened. First we get the value R1, R2. If both the resistance are present, we get R1, R2 divided by R1 plus R2. For example, you have to consider one is 2 ohm and another one is 3 ohm. Okay, 3 plus 2. So 6 divided by 5. So 1.2 ohm. Okay. So one is 2 and another one is 3. I have to remove the 3 ohm resistance. Now the total resistance will be increased. So first one is correct. Total power. The power is the addition of P1 and P2 for the parallel combination. So addition means if one of the power is removed, so decrease, the power is decreased. Here the voltage, the same voltage, the first branch the voltage V, second branch also the same voltage because it's a parallel combination. So no change in the voltage. These three are correct. That D is the correct answer. Next problem. How are 500 ohm resistor connected so as to give the effective resistance of 750 ohm? See the first one, have to consider from the answer only we are going to find out the correct one. So 3 resistors 500 ohm each in parallel. So each in parallel means what about the resultant? That is 500 divided by 3. So the value should not equal to 750. 3 resistors of 500 ohm each in series. At that time also we'll get the summation of 3500. And see, 2 resistors are in parallel. So here we get 500 by 2. And the last one should be a correct answer. So 2 resistors of 500 ohm each in parallel. So parallel means that is 250. Correct. And the combination in series with 500. So that is equal to 750 ohm. That is our answer. So D is the correct answer. Next. In a given figure, the value of resistance R in ohms. Okay, see here. I am going to apply the nodal analysis to find out the resistance. So in a node, I have to mark the voltage V. I am going to apply the nodal analysis. So before that, I have to assume the direction. All the currents are flowing away from the junction. See, here the current is flowing towards. Both the currents are opposing with each other. How to write the equation? V minus 100 divided by 10 plus V minus, here this is the ground potential 0. So V minus 0 by 10. You see both are in the same direction. The answer is plus 2 equal to 0. So first of all I have to separate V. V of 1 by 10 plus 1 by 10. That is equal to what? 100 by 10 minus 2. Okay, 10 minus 2, 8. Here V into 2 by 10. So 5. So V is what? 40 volt. The first answer is okay. Next I am going to find out R. Here see, the same voltages appear across R also. What is V? V is equal to I into R from Ohm's law. I am going to find out R. R is equal to V by I. Now what is V? What's the value of V? V is the V by I. What is the value of V? 40. This is a known value. What is the current? 2. So what is the resistance? 20 ohm. So 20 ohm is the correct answer. Then in the circuit shown in figure, what is the value of R will result in I is equal to 4 ampere. Okay, see here. Here also I am going to apply the nodal analysis. See, all the currents are flowing away from the node. See, this current is flowing towards it. Both the currents are opposing with each other. So how to write the equation? Using nodal analysis, we can write the equation. So V minus 100 divided by 12. Then V minus 0 by 40. Next minus 4 equal to 0. So V into, take V separately. So V into 1 by 12, 1 by 14. That is equal to 100 by 12. Here plus no. So minus 4. Next, the LCM is 12 into 14. So V 14 plus 12, 14 into 12, that is equal to 48, that is 52 by 12. Both the 12s are get cancelled. Here 26 no. So 26, here 2. What is the answer? V is equal to 28. 28 volt. So after getting V, using Ohm's law, we can easily find out the resistance value. So what is resistance? V by I. What is the value of V? V is equal to 28. What is I? 4. So what is the resistance R? R is equal to 7 ohm. So 7 ohm is the correct answer. That's all. Thank you.